Okay, ladies and gentlemen, we will now begin the moment for automotive discussion. We've got 5 experts to be getting on the stage and sharing their experience and their missions with you. So, the first speaker I would like to invite on stage is from the CRP group, which is an innovative manufacturer of supersport motorcycles and much more. He will be here to explain. Please, a round of applause for the Additive Manufacturing Specialist at CRP Technology, José Antonio Almenara.
Very much. Okay. Hello, everybody. Thank you very much for inviting me here. Okay, well, just to give you a brief introduction to CRP. CRP is a company made of 4 main companies. The first one is CRP Mecánica, which is specialized in high-precision CNC machining. Started very long time ago. Another company is CRP Technology and her sister in the USA, which is CRP USA, which are specialized in developing 3D printing solutions and owners of the WinForm material for 3D printing SLX technology. And the 4th company is the last one, our spin-off. It's Energica Motor company. It's a company which has developed the first Italian super sport bicycle. The main business of CRP technology in this case is motorsports. Automotive motorsports are the main applications, mainly 80% of their business. But we also have some projects working in aerospace, drones, UFs, and in other applications like sports. We are based in Italy, in what we call in Italy the Motor Valley, which is the place where several motorsports and automotive companies were born, like Ferrari, Lamborghini, Maserati, and it's part of our DNA of this automotive inside us. We also have our factory in the USA, which is in North Carolina. Well, CRP Mecánica started in 1970, giving CNC machining for companies around us, like F1, Scuderia Ferrari, and CRP Technology started in the mid-90s, where we bought our first 3D printing machine, which we still use nowadays. And we started developing our own SLS materials, which we call WinForm. And WinForm was initially used on wind tunnel applications. It helped develop the wind tunnel models to test inside motorsport companies. And that's where what we call from rapid prototyping. And we like to say that we started from rapid prototyping, and now we are into additive manufacturing. Because at the start, we only look at giving parts that could just reproduce a part of a car or a machine. And now, with additive manufacturing, which is a bigger word, let's say, that we are actually doing some parts that can have functional applications, and that can be used into cars or well, at least small series productions. Hopefully, in a future, big production cars will have our parts, our materials. And in 2005, we launched our WinForm XT, which was our biggest innovation in those years. It was the first ever carbon field material. It was very tough in 13 years ago, and it suddenly get so much appeal into motorsports, and we started working with every F1 team and producing different components, not only for wind tunnel applications, but also that they placed in the car during testing, and also in race days. In 2015, we improved our WinForm material. We call it XT 2.0, and it improved the mechanical strength of the material. Here you can see some specs from WinForm material. You can see the heat deflection temperature, which is almost 200 degrees. The tensile strength, which is 83 megapascal, and it's actually one of the best material for UTS, actually in commerce. We have passed also several tests. Before you were talking about aerospace, and this material is being used in several satellites, and it has the certification of NASA and ESA Institute. We not only have one carbon field materials, we have another material which is WinForm SP, which the request from producers was not only to have the strength of the material, but also to have some elasticity, being able to support heavy stress, vibrations, and that's why we developed the WinForm SP that has less tensile strength, but its elongation and elasticity is bigger. Apart from carbon field materials, we also developed glass fiber materials, which the WinForm LX, which is our entry-level material. It has very good mechanical properties, and it's mainly used because of its dielectric properties. It's CTI rating 600, and if you get to see our bike, which is just right there, some components inside the battery pack, they're done with WinForm LX because of the dielectric characteristics of the material. The other material we have developed in glass fiber reinforced is WinForm GT. It's the antithesis of WinForm LX. It's a very elastic material, and I will speak about that seat plate later on. Well, this is just to explain to you which is the evolution, why we say when we start from racetrack, we go into the road and get back into the road. CRP technology is CRP Racing at the time. It was a company which was involved in motorcycle races. It has won several Italian and European championships until 2010. In 2010, we changed into electric, and we started working into the European Electric Championship. In 2010, as I said, we decided to open Energica, which was this company creating sustainable vehicles and transferring our background from racing into doing a super bike, and which had all the racing breed and also all the statics from Italian motorcycles. And in this case, CRP was the main incubator, not only financially but also technologically, given their knowledge from 3D printing and from CNC machining to develop the motorcycle. In January 2016, the company was quoted in the Borsa Milano for alternative investment market. It's the big step that led Energica to be a company kind of on its own, apart from CRP Group, and to start building the motorcycles in a serious production. This is what you can see in the middle. Is the prototyping, the first prototype of our motorcycle. You can see all the chassis. All the chassis is made from rapid prototyping done with our WinForm materials. Several other components on the motorcycle were done in rapid prototyping. And what you see in the upper my left is the Energica Ego. The one on the bottom is Energica Eva, and our last motorcycle is SS9. And what you see here is it's the motorcycle that's going to be running next year on the Moto E, which will be official providers for the motorcycles. Now let's talk a bit about our motorcycle. This is the Energica Ego, the first model we developed. And just to give you some examples of how you can use additive manufacturing into developing a motorcycle, the dashboard. The dashboard was something that we started developing the first dashboard model on our materials. In this case, was WinForm LX, because of the electricity of the material. We were sure there weren't going to be any shortcuts at all. And the first stage was to develop the statics, giving different versions of the shape of the dashboard in order to improve on the design. And when we had the final revision of the design, we started developing the nesting inside the dashboard, placing all components, and the possibility to have in-house the machines. And the technology allows us to make different versions in order to package the best way possible all electrical components inside the dashboard. And the last stage was the stage where we had to decide to go into injection molding, and we have all the geometries. We went to the injection molder manufacturer, and we said we want it like this, and we showed him the dashboard as we wanted it to be in the final stage, with all the specs, all the fit and flash perfectly done, and it was a really easy way to improve toward the development of a dashboard. Dashboard was developed in I think it was 8 months at all. Consider that we were at that time a really small company, 10 people working in the whole company. Another thing that we developed with 3D printing, that you can see that's just behind our motorcycle. It's the seat and the seat plate. This is a mix of 2 of our materials. We have WinForm GT for the seat plate, and we have WinForm RL, which is a rubber-like material, which help us develop the seat. The seat plate was, in fact, something tricky to do, because we needed a material that could support the weight of the test pilot, and all the vibrations and the heavy loads from riding, from testing the motorcycle on actual roads and tracks. And we say that we did several iterations on reinforcing the plate, and at the end we got a seat plate that was fully built in WinForm GT. The other part, the seat, it started like an experiment, which we wanted to define which was the right hardness that the seat should have. And at the start, we printed fully on full density the seat, and we placed it into the motorcycle, and it was too hard for the pilot for the test pilot, and he said, "Oh, I need this to be more smoother," and that's why we printed the seat using let's say less density in order to make the foam more softer. And we did like this several different in order to get the right smoothness, the right stiffness of the seat. And also with these two components, we went to the seat manufacturer and tell them, okay, we want the production part to be just like this. And it was really easy for us to develop this. The last one was our battery pack, which is probably the most important component in the motorcycle. The battery pack, on the first design, it was fully built on WinForm. It was on WinForm GF, which is a glass reinforced with aluminum as well. And we did the first pack for several purposes. The first one is to place it into the chassis of the motorcycle, and to test all the correct fixings of the chassis. Afterwards, we use it to do the packaging of all the packing cells and do the routing of the cables, and to test all components. In this phase, the battery wasn't able to ride with the motorcycle because it's a structural device, but it helped us develop all this stuff, and also for the tooling phase, because we did all the CAD/CAM with the help of the 3D printed machine. We placed it under the CNC machine, and we started doing all the machining, and to see if there were any problems at all. And we got to improve on time on developing time with this solution. Then the next stages of the battery pack, they were obviously in aluminum, but it all started with 3D printing. Last, as I was telling you, next year we're going to be the single manufacturers for Moto E, and it's going to be our motorcycle for racing, and this is our let's say we have returned into racing, starting from racing, getting into automotive, and back to racing. That's all. Thank you very much.